Hi folks, Mr. Long here. I'm going to do a screen recording for a tool that's going to help you do polynomial long division with the box method. And it's just something I made up in the spreadsheet application for Google Docs. And so I'm going to go through this with you. So here is off to the right, if you can see over here, I'm moving my pointer. You can see an equation there, a polynomial equation of degree 3. X cubed minus x squared minus 10x minus 8 equals 0. And what we do, folks, is to solve that equation, as you know, is you've got to test it out with remainder theorem and find an x-intercept, which we call p. Anyway, so moving over here to this spreadsheet, which I'm going to post a link to that on our Google Classroom, you can see I put the coefficients in. So you can see up here, it's for ax cubed, bx squared, cx, and d equals 0. So a equals 1 in this case because it's x cubed. B is negative 1 because it's negative x squared. C is negative 10 because it's negative 10x, and the constant is negative 8, therefore d is negative 8. And then what we can do is, you can see here, if use the remainder theorem to test that the remainder equals the function evaluated at p until r equals 0. And then you have factor theorem. So if the remainder is 0, you have a factor. So I'd already worked with this. So what I'll do is say I tried, what should I try, by the way? The constant is negative 8, so that would mean all the factors, and the number here is 1. So I could test all factors of plus or minus 8. So 3 would not be possible. 1 might be possible, but it's not. So I could try negative 1. Is that possible? Yes, negative 1 actually works. So p equals negative 1 works. So that means that an x-intercept is x equals negative 1, and a factor would be x plus 1. So then what we do is go down to the actual box, which I've shown right here. Okay, and it's just like the box that you learned in class. Now, what I want to be clear about right now is that the only places you enter data in or numbers in is where the boxes are yellow. Okay, otherwise you shouldn't be entering data in. So we've definitely got a 1 here, 1x there, and then we've got, this should be x plus 1, right? So it's x plus 1, and then I go to, because p is negative 1, so this is actually going to be a pretty easy multiplication one. So I've got, so I'm starting off with 1x cubed, and then I do 1x cubed divided by 1x to get 1x squared, right? And then after that, I'm just going to change these because I think the answers are right here. I want to make sure that we go through this properly. Okay, so once I do 1x cubed divided by 1x, that gives me 1x squared. Then what I do is I take 1x squared and I multiply it by 1, which would give me 1x squared. Then I go to the next one, and I know that along the diagonal, so right from here to here, along this diagonal, these need to add up to negative 1, right? The original equation was 1x cubed minus 1x squared. So the squared's diagonal has to add up to negative 1. So this is 1. This has to be, what 1 plus what number is negative 1? Well, it's negative 2. I've got negative 2. So then I do negative 2x squared divided by 1x, and that would give me negative 2. Okay. And then from there, then I do negative 2 times 1, which would be negative 2. And then in the next diagonal, negative 2x plus, that should have been an x there, oopsie. So negative 2x added to 6, and well, that's not 6, but what number do I put in this box? Negative 2 plus what number adds up to negative 10? Well, I think that's, so negative 2 plus what number is negative 10? Well, that would be negative 8. So I enter in negative 8, and that does equal negative 10. So now the nice thing is that this checks for me to see if my diagonals are right. So I should have 1x cubed, I have 1x cubed. I should have negative 1x squared, I've got negative 1x squared. I should have negative 10x, I've got negative 10x. Oh, wait, I didn't do the final calculation though. So now I have to do negative 8 divided by 1 is negative 8. And then I've got to do negative 8 multiplied by 1, which would be negative 8. And if I've done it right, there should be 0 remainder, right? Because I'm working on the premise that x plus 1 is a factor. Okay, so then that division is equal to 1x squared minus 2x minus 8. So if we go down here, it will actually input the correct answers for you. So it doesn't look very clean because it says plus like a negative, but here's your original one in the top line. So 1x cubed plus negative 1x squared, or minus 1x squared, minus 10x minus 8 equals 0. That's the equation we were trying to solve. So it worked out that x plus 1 was a factor. I got that by factor theorem and remainder theorem. And then here's the quadratic that was left over, x squared minus 2x minus 8. Now it says you can factor the quadratic again if possible, or use the quadratic formula to solve. But this one would look pretty easy to solve, I think. It's got to multiply two numbers that multiply to negative 8 and add to negative 2. So that's going to be negative 4, positive 2. So it'd be x minus 4, x plus 2, and then the x-intercepts would be the opposite of those. So again, that's just a tool. So to input your numbers, and it just makes it a little bit faster to work through. It gives you a structure. You still have to do the work, but it always checks for you to see if your diagonal's right and a few other things. So anyway, I'm going to post this online on Google Classroom, and please feel free to use it. The only other thing I would mention to you is that there's two tabs you're going to see there. One tab is going to say manual. That's the one you want to use. The other one is automatic. It actually does the calculations directly for you. And you don't want to practice with that, I don't think. But again, it's a calculator there for you. Okay, hopefully that helped.